What's up, everyone? Welcome back to algebra. Now we finally get to learn the main part of algebra today. Functions. Now, before we start on this one and identify functions, we need to know what is the difference between a relation and a function. Function. A relation is a set of two variables, x and y, that have certain related values to each other. A set of ordered pairs. Examples include a graph of the variables, a set of ordered pairs, and a table. And then, alright, so that's what you're all going to see in this lesson. All of them are relations. But what exactly are functions? Functions are relations where for every input x, there is only one output y. Pretty interesting. So for every input, there is only one output that matches it. So based on these, let's see if you can try to identify some of them. So here's an example. So we have this set of ordered pairs here. Here's here. We have negative 2, 1, negative 1, 0, 0, 1, 1, 4, 2, 9. Alright, so is this a function? Well, you need to take a look and see if there are any repeats in the next value. Those the variables on this side, the left side. If there are any repeats, then we do not have a function, unfortunately. Alright, but as we can see, now we might have a repeat on the y values, right side, but they do not play a factor in determining if it's a function or not. So, we can see that for every input x, there is only one output. Therefore, this is a function. Why don't you try it out? Is this a function? Take a guess. See for yourself. Alright, so here we have our set of coordinates here, ordered pairs. Now notice what we got here. We got a couple repeats and x values. Notice that -2 shows up twice and with one input, there are two outputs, 1 and 10. Same thing with input -1, two outputs, 4 and 7. So the function rule does not exist here, and this is not a function. All right, so now we got ourselves. Now let's see if you can try to identify with tables. How about I actually do it? Is this good enough for you? All right, then how about this? All right, so there's our x values. All right, take a look what we got here. I jumbled up the order this time. I'm a little bit, but you should be able to notice that there's only one x input for every output. Both of the outputs 4 and 3 are repeated, but again, that is not a factor into what determines a function. So therefore, one input, one output, function. Simple. Okay? It's not as hard as you think it is. Yes, do not stress it. Okay? Alright. How about you get something like this? Alright, so tell me, this is a function or not? Okay, so the answer is this is a function. So we have -10, -5, -1, -11. No repeats, one input, one output, function. Alright, so I gave you two different ways, and I asked you to tell them if it's a function or not. I got one more for you. So now I'm going to talk to you about the vertical line test. So the vertical line test says a relation is a function if and only if a vertical line cannot connect two or more points on a graph. So a vertical line must intersect a line 0 times or 1 time. That's it. So allow me to show you of an example of something that does not pass the vertical line test. I'm just simply going to draw something like this. Alright, so notice that the line that I just drew right here on my coordinate plane. It's terrible. It's a terrible relation here. We got vertical lines all over the place. We got vertical lines all over the place. this is definitely not a function. It definitely does not pass the vertical line test. Alright? How about this one, though? Is this a function? Tell me if it is. No? Let's examine. Pass, 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 fail. Look at that. I tried to draw a perfect, like in a vertical line here. So, notice that we got a vertical line here. So this is not a function, and because it does not pass the vertical line test. Alright, last one. Is this a function? The correct answer is yes. This is actually the graph of something that we call a cube root function. That's something you're going to get into algebra 2, so don't need to worry about that. Alright? Now, do you think this, what I'm trying to draw right here, is going to fool you? Do you think this is a function? Huh? 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 No. No. So, a function may have only integer values. But that does not mean that it's not a function. Function. You can still try to draw a line through the points. It's just gradually increasing from here, guys. So this is a function, right? Because it passes the vertical line test. How about one more? Let's say you got something like this. Is this a function? It might be easy for you to say yes, but the answer, I mean, it might be easy for you to say no, because look, we got a vertical line. It doesn't pass. Guess what? This actually passes. You can tell that this passes because this dashed line we drew right here, that is what we call an asymptote. So notice that as we approach this value at x equals 1, it's just going to get closer and closer and closer and closer, but it does not intersect. It doesn't just stop and stop right here. It's just very hard to tell. So if you see an asymptote, then chances are it's a function. Okay? Alright. I've had enough fooling you around. Alright. So, now I'm going to tell you about the two parts of a function. Domain and range. Domain is the input values of a function for x, and the range is the output values for y. So let's see if I'm going to give you a little function right here. So we're going to try and approximate this. Make this. here, and let's say that this is the endpoint right here, 5, -1. And then we have another endpoint right here. Let's say this is 3, 3.5. Alright, so now you're being asked, what is the domain and range of the function here? Well, notice that I told you that these are two endpoints here. So, we can say that the domain here is 5, oh not 5, -5 is less than or equal to x is less than or equal to 3. And the range, well, we go from the bottom to the top. So that'll be -1 is less than or equal to y. It's less than or equal to 3.5. And that's how you find the domain and range of a function, just by looking at the graph. Pretty interesting topic, huh? Now I will tell you that in pre-calculus, your teachers are going to hit you hard with trying to identify functions and defining domain and range. Alright? How about you try this one? So, what is the domain and range of the function here? Okay, so we have an endpoint right here at the origin, 0, 0. And then notice that we have a little bit of an arrow or array going on, meaning that the function goes on forever in that direction. So it's just going to keep going on forever in the right direction and in the up direction. It's never going to stop. This is actually what we call the square root function. Again, algebra 2. But anyways, we're going to list off the domain. Here's how I would do it. I can describe it as x is greater than or equal to 0, and the range is y is greater than or equal to 0. Pretty simple, right? Alright. Now, those are what we call continuous functions, where all real numbers in the line we just drew are solutions to the function. Now, you might come across in the real world where you really can't take a fraction or decimal of something. Like, let's say that you're trying to raise money and you charge $18 per ticket, so y equals 18x. You can't really split a ticket now, can you? So these are the times where we would have discrete functions, where only certain numbers are represented in the function. So here's an example. So we have a point here at -3, and then 3, 4. What is the domain and range of this function? Well, we are still going from endpoint to endpoint here. Point to endpoint here. And we are going, so we can really describe this very simple. So we have left side x value, -3 is less than x, it's less than or equal to 3, because that's the right side maximum value for x. And then the range, -3 is less than y, is less than 4. Okay, so so now I'm going to give you one more, and then we're going to close off for the day. All right, how about this one? What is the domain and range of this function? Well, notice that we got ourselves a line, which is which is something with 2 arrowheads, meaning they can continue on forever in both directions. This is what we call a linear function, in which we're going to be talking about next time. All right, so we have domain and range. What is the domain and range anyway? Well, notice that we have the arrows going on forever in all directions, and there seems to be no turning point. So we can describe the domain and range as all real numbers, which would be best represented by these symbols. Alright, so that is how we identify functions, and those are the different properties of functions. Alright, so we're going to be starting linear functions starting in the next lesson. Yay! So in the next lesson, we're going to be learning about next few lessons, we're going to talk about linear functions, function notation, linear equations in standard form, linear equations in slope-intercept form, absolute value functions, transformations of graphs of functions, equations of parallel and perpendicular lines, and then piecewise functions. Yes, that's all going to be in our linear functions section. And I hope that you enjoyed this first lesson in our second unit for the math series. Thank you so much for those who have been supporting me these past, what is it now, like 11 videos that I've been making. This is my 12th. Yes, thank you so much, guys for taking the time to watch these. Be sure to leave a like and subscribe to my channel for more videos. If you really like this video, please share this with your friends. I want to help out as many people as I possibly can, just so they can get a better understanding of high school math and how it's applied to the real world. Okay, so thank you so much for attending, and hope to see you again next time. Bye.